In the previous session, we have now introduced the concept of the limit. I've taken 2-3 examples also. You can just refer the examples given in the textbook. There are a number of examples with, tabular data you are given, so you can just refer those examples. Now we'll move ahead. The next point is about working rules for limits. That's also called the algebra of limits here. Right? That is how to add, subtract, multiply and divide two limits. Algebra means this. So here first one, that is if you have limit x tends to a और आपके पास एडिशन है दो फंक्शन का fx plus gx. So this first rule says that you can take limit inside. आप the simple linear property है, limit अंदर ले सकते हैं आप. That's addition. If you have two functions, you can take the limit inside the bracket. What this rule says, there is nothing to remember. इतना ही बोल रहा है कि आपके पास ब्रैकेट है तो फंक्शन को अंदर ले सकते हैं, ब्रैकेट ओपन कर सकते हैं. सेम थिंग ऑल्सो होल्ड्स ट्रू फॉर माइनस इवन. सो आई विल जस्ट राइट हियर लिमिट. ओके, लेट मी राइट हियर ओनली. इफ यू हैव माइनस, हियर ऑल्सो माइनस. सो प्लस माइनस है तो लिमिट अंदर ले सकते हैं. The next property is limit x tends to a. Suppose you have some constant here c into fx. Then this rule says that you can take constant outside or limit खाली function को apply कर दो of fx like this. What this says, if you have limit x tends to 2 like 4x square, so this says you take 4 outside and just apply the limit to the function. राइट एंड ये आप जानते हैं, यू नो. सो ये आंसर 4 आएगा. सो 4 into 4 लिमिट इज 16 लाइक दैट. दिस वी डिड, ये हम लोग ने किया है. 4 into 4 so 16. What's the meaning of this? Whenever x is very close to 2, then this function is very close to 16. You can try by calculator. Take a number very close to 2. Suppose I have taken 1.999 like this. अब ए वैल्यू यहाँ पे रखो 4 into 1.9999 होल स्क्वायर. यूज़ द कैलकुलेटर. यू विल नोटिस दैट ये जो आंसर आएगा इट विल बी वेरी क्लोज टू 16. दिस इज जस्ट आई एम को रिलेटिंग विद द डेफिनेशन. राइट, इट हैज़ टू बी ओके. एवरी टाइम आपको सम्स में ऐसा करना नहीं है, बट दिस इज जस्ट बिगिनिंग, दैट्स व्हाई आई एम टेलिंग यू. ओके, सो इफ यू हैव कांस्टेंट वेयर सी इज सम कांस्टेंट, लेट मी राइट हियर, then that constant will go out. Okay, third one, that's for the multiplication. Limit x tends to a. If you have fx into gx, product of two functions, then limit x tends to a of fx into limit x tends to a gx. Product में भी आप individual limits apply कर सकते हैं. Limit of the first function into limit of the second function. For product, even you can take the limit inside. For addition and subtraction, you had noted. Now I'm saying for product. Fourth one, that's obviously division rule. Limit x tends to a of fx upon gx, then gx should be non-zero, remember. Upon 0 नहीं चलता, आप जानते. So then also you can apply limit to numerator fx अपॉन लिमिट टू डिनोमिनेटर. डिनोमिनेटर फंक्शन को भी लिमिट जाएगा. लिमिट ऑफ न्यूमरेटर अपॉन द लिमिट ऑफ द डिनोमिनेटर. ये लिमिट 0 नहीं आना चाहिए, रिमेंबर. ये लिमिट 0 नहीं होना चाहिए. सो आई राइट द लिमिट ऑफ द डिनोमिनेटर फंक्शन शुड बी नॉन ज़ीरो. ये भी नॉन ज़ीरो ही होना चाहिए. लिमिट एक्स टेंड्स टू ए ऑफ जी एक्स. सपोज इसका आंसर 0 आया तो ये अनडिफाइंड हो जाएगा. फंक्शन तो नॉन ज़ीरो होना ही चाहिए, बट लिमिट भी नॉन ज़ीरो होनी चाहिए. फाइन. सो these are the 4 standard working rules, which is also called the algebra of the limits. What it says, very simple. इसमें कुछ याद आपको मेमोराइज नहीं करना है, खाली इतना याद रखना है. इफ़ यू हैव प्लस और माइनस, you can take the limit inside. If you're constant, you can take it outside. If you're into, again individually you can apply the limits. If you have division, again you can apply individually. Fine. एंड यहाँ पे इम्पॉर्टेंट है कि ये भी नॉन ज़ीरो होना चाहिए और लिमिट का आंसर जो आ रहा है वो भी नॉन ज़ीरो होना चाहिए. These are the standard for algebra of limits, or these are also called the working rules of the limits. Okay. Now next we go for you can call the results connected to limits, or you can call the formula for the limits, right? Which we use to solve the sums, remember. Every time to prepare the table, and it's not easy task. Trigonometric function hai, so how do you find sine 1? You don't know. Right? So that's why this formula is important. If you have some complicated function, you cannot go through the tabular method which I've explained in the first session. It becomes very tedious and difficult to remember. So we have some results which are theorems, you can call the results, you can call the formula, but we'll use this to solve the sums. We use to solve the sums of the limits, to solve the examples of the limits. Examples of the limits, remember, which we use to solve the examples of the limits. ये use करेंगे हम लोग. ये सबका proof है. All are like individual theorem, remember. I'm not proving. I'll just give you the basic idea. Textbook में सब proof है. First question, first result. That's a limit x tends to a, और यहाँ पे आपके पास constant function है. fx equals to c. Right? This is called which function? Constant function. आपको याद होगा टाइप ऑफ फंक्शन में. कांस्टेंट फंक्शन मीन्स व्हाट? हर बार फंक्शन का वैल्यू फिक्स्ड ही है, सी 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 सी. तो क्या होगा? वेरी इजीली यू कैन इमेजिन, ये तो हर बार वैल्यू सी ही रहने वाला है. यहाँ पे आप कुछ भी रखो, मैं यहाँ पे एक्स का वैल्यू कोई भी ले लूँ, एनीथिंग विच एवर यू चूज, बट फंक्शन का वैल्यू तो हर बार सी ही है, सी 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 सी. सो this function is very close to c again. So what this result says? Limit of a constant function is constant. What it says? Limit of a constant function, limit of a constant function is constant. कांस्टेंट चेंज होने वाला नहीं है, आपको पता है ये वैल्यू. ये बार जो यहाँ पे जो टेबल फॉर्म हो रहा है वो तो हर बार सी ही होगा. आप x का वैल्यू कोई भी चूज करो, इट्स इंडिपेंडेंट ऑफ चॉइस ऑफ वैल्यूज ऑफ x, रिमेंबर. फाइन. इट्स वेरी ऑब्वियस बाय दोज टेबुलर टेक्निक. इफ यू गो दिस इज कांस्टेंट, कोई भी वैल्यू ले लो हर बार सी रहेगा. लाइक दिस, लिमिट x टेंड्स टू 0 ऑफ 4, तो इट विल बी 4 ओनली. फंक्शन का वैल्यू 4 ही रहने वाला है. यहाँ पे आप 0 रखो या 100 रखो. इफ आई राइट दिस, लिमिट x टेंड्स टू -1, यहाँ पे मैं 2 रखूँ तो आंसर विल बी 2. आप x का वैल्यू कोई भी रखो बट फंक्शन का वैल्यू हर बार 2 ही है. इफ आई राइट दिस, लिमिट x टेंड्स टू, सपोज आई विल राइट हियर 20, और यहाँ पे रखूँ मैं -1, तो फंक्शन का वैल्यू फिक्स्ड ही है -1. ये फंक्शन का पोजीशन है, फंक्शन का वैल्यू हर बार -1 ही है, तो इट विल बी वेरी क्लोज टू -1. लिमिट x टेंड्स टू, आई विल राइट हियर फॉर एग्जाम्पल 1/2, और यहाँ पे रखूँ मैं 10, तो फंक्शन का वैल्यू 10 फिक्स्ड ही है, तो लिमिट विल बी 10. So what the first result says? Limit of a constant function is constant. Fine. Let's go to second result now. Result number 2, which I already explained. That's first, it's about linear function. Limit x tends to a of x. So it's obviously a only. अब x के जगह पे a रख दो तो ये आ जाएगा. It's very simple function. You prepare the table, you will realize. अगर मैं a लिखूँ, लिमिट x टेंड्स टू a x स्क्वायर कर दूँ, तो ऑब्वियसली a स्क्वायर हो जाएगा. फाइन. सो इन जनरल दिस इज द रिजल्ट. लिमिट x टेंड्स टू a, x रेस टू n है तो a रेस टू n आ जाएगा. इट्स वेरी सिंपल बेसिक रिजल्ट, रिमेंबर. इट कैन बी प्रूव्ड ऑल्सो लाइक दिस. सो अगर मैं यहाँ पे लिखूँ, वी ऑलरेडी डन दिस, लिमिट x टेंड्स टू, इफ आई राइट 2 हियर, मैं x स्क्वायर लिखूँ, तो आपको क्या करना है? x के जगह पे 2 रखना है. 2 स्क्वायर विच इज़ 4, विच यू डिड बाय टेबल. अपने टेबल थ्रू तो किया ही है, बट आई एम शोइंग नाउ बाय रिजल्ट्स, एंड इट कैन बी प्रूव्ड ऑल्सो. through some theories. But this is not hard to believe. इतना डिफिकल्ट नहीं कि आप मान नहीं सकती. If x is very close to 2, then x square will be very close to 2 square naturally. Okay, so here limit x tends to a, x raised to n is a raised to n. If I take one more example here, एक और example ले लो. For example, see this. Suppose I have this limit x tends to 1 x cube. The answer has to be 1 cube, which is 1. मैंने क्या किया? Just x की जगह पे 1 place कर दिया. That's what this result says. What this result says, x is replaced by a, remember. If I have this limit x tends to 0, suppose I have x raised to 4. So answer has to be 0 raised to 4, and which is 0. Fine. You can try, take values of x very close to 0. Suppose मैंने x का value ये लिया 0.00001, right? Now a value of fx बराबर x raised to 4 में रखो. So what we'll get? 0.0001 whole raised to 4. तो we'll see that this is also very close to 0. ये जो value आएगा वो 0 के पास ही जाएगा, तो limit has to be 0. Tabular method, but here we are using this result. So two important results. Result number 1, limit of a constant is constant. Result number 2, limit of x raised to n is a raised to n. Now your next result, which is very important, which is about power function here. Let me write as a third result, result number 3. That's limit x tends to a, you have x raised to n minus a raised to n about x minus a. Three things we observe here. Such type of the function. ऐसा function होना चाहिए. Which type of the function? These two powers should be same. This can be any number, remember. Maybe fractional or integer, anything, remember. So you can write n belongs to q here. It can be integer or it can be fractional number also. Q means rationals, you know. Okay. Now which three things we notice here? दोनों जगह पे minus होना चाहिए ऊपर नीचे. Both the places. It should have minus sign, remember. Like x raised to 3 minus 2 raised to 3 upon x minus 2, right? You should have minus, both should be equal, 3, 3. And अब power को drop कर दो तो देखो same दिखना चाहिए. Drop the power, both should be same. Power drop कर दो, both should be equal, numerator and denominator. Then the limit of this expression. Now when I use the word limit of this expression means what? Whenever x is very close to a, then this function is close to which number? That's the question. So that is close to this number, n into a raised to n minus 1. I repeat, n into a raised to n minus 1. Q, as I told you, it is a theorem. It can be proved by binomial theorem. You know now what is a binomial theorem. I'll not get into that. If you are interested, you can refer the theory. Textbook में है एक theorem है. But what is important for us is what this statement says. Whenever x is very close to a, then this function, a जो function है, this would be very close to this, and that's declared as the limit of the function. Now ये कहाँ से आया? तो ये जो टर्म है उसको आगे ले लो, एक पावर लेस कर दो. Probably you might have used such concept in differentiation. आपने ऐसा लिखा होगा, derivative of x cube is 3x square, probably in the physics. I don't know. नहीं लिखा तो कोई बात नहीं, हम लोग करने वाले ये चैप्टर में अगले वाले पार्ट में. लिमिट ऑफ डेरिवेटिव ऑफ x रेज टू 4 आपने 4x क्यूब किया होगा. यू टुक दिस 4 इन प्रोडक्ट एंड यू रिड्यूस द पावर बाय 1. एक ये जो फॉर्मूला है डेरिवेटिव्स का वो यहाँ से आ रहा है, एक्चुअली उसका रूट से है. सो दिस number will be in the product and one less power. That's the limit. Whenever this variable is very close to a, then this function, ये पूरा function है हमारा, this function is very close to this right hand side expression, n into a raised to n minus 1. Fine. अब आपको बिगिनिंग में देखा था कि मैं x की जगह पे a रख दूँ यहाँ पे डायरेक्टली सपोज, सो a रेस टू एन माइनस a रेस टू एन ज़ीरो हो गया, यहाँ पे भी a रख दूँ a माइनस a ज़ीरो, सो ऐसा फॉर्म हो गया 0/0. यू माइट बी नोइंग दिस इज़ अनडिफाइंड, ऐसा होता ही नहीं है, आप कैलकुलेटर में ट्राई करके देखो, यू विल गेट द एरर. अपॉन ज़ीरो आया ना, दैट्स अ प्रॉब्लम. सो ऐसा अनडिफाइंड फॉर्म हो जाएगा. तो आपको दिख रहा है अनडिफाइंड बट स्टिल लिमिट एग्जिस्ट, रिमेंबर. दैट्स वाई वी हैव एक्सप्लेन द कॉन्सेप्ट ऑफ द लिमिट इन द बिगिनिंग, वरना डायरेक्टली ही ना लिखवा देते, डायरेक्ट एक्स की जगह पे ये रख दो, बट दैट्स नॉट द कॉन्सेप्ट. गेटिंग मी? सो if you place the value directly you will not get the limit, you need to use the proper concept, proper formula. आपको फर्स्ट लुक पे लग रहा है ये तो हो जाएगा 0/0 एंड यू कैन नॉट कैंसिल 0 एंड आंसर इज 1, इट्स रॉन्ग, दिस इज अनडिफाइंड. व्हाट इज कॉन्सेप्ट हियर? इफ x is close to a then this function close to which number? तो here this number is n into a raised to n minus 1. तो इसका आंसर क्या आएगा? ये 3 प्रोडक्ट में जाएगा and here 1 less power, so 2 raised to 3 का 1 less 2, so answer is 12. 3 into 4 12. So what you have concluded here? Limit x tends to 2, x cube minus 2 cube upon x minus 2 equals to 12. Now you can try, आपको अगर देखना है तो you take one values of x very close to 2. This is just for your information, करना नहीं है, आपको बता रहा हूँ. सपोज मैंने लिया x बराबर 1.999, वेरी क्लोज टू 2 लिया नंबर. अब ए नंबर आप यहाँ पे रखो, यू राइट 1.999 होल क्यूब, ये आपको पता है 8 है, अपॉन यू राइट 1.9999, ये 2 है. यू विल नोटिस दैट बाय कैलकुलेटर इसका जो आंसर आएगा इट हैज़ टू बी क्लोज टू 12, 11 पॉइंट समथिंग होगा, लाइक 9898 और समथिंग लाइक दिस, विच इज़ क्लोज टू 12. एग्जैक्ट 12 नहीं आएगा, वो तो कॉन्सेप्ट है लिमिट का, हम लोग हर बार क्लोज वर्ड यूज़ कर रहे हैं. यू कैन ट्राई दिस मच, यू विल रियलाइज. सो यू विल फील दैट वॉट यू डिड बाय फॉर्मूला इज राइट. अगर आप ऐसा कर देंगे तो दिस इज़ रॉन्ग. रिमेंबर, मैं ऐसा कर दूँ कि भाई ऊपर को लिमिट अप्लाई कर दूँ, तो 2 raised to 3 एक्स की जगह पे 2 रख दिया, दिस इज कॉल्ड द सब्सटीट्यूशन. माइनस 2 raised to 3, ये कितना हो गया? 0 हो गया. यहाँ पे 2 रखो, 2 minus 2, तो आपका आंसर क्या? 0/0, कैंसिल इट 1. ये ट्रू है? नो, दिस इज रॉन्ग, ऐसा नहीं होता है. 0/0 अनडिफाइंड फॉर्म है, रिमेंबर. सो वेन एवर योर अनडिफाइंड फॉर्म यू नीड टू स्टॉप फॉर ए वाइल एंड यू नीड टू थिंक कि कुछ फॉर्मूला से हो सकता है. दिस इज नॉट द राइट वे ऑफ डूइंग द लिमिट्स और इवेल्युएटिंग लिमिट्स. गेटिंग मी? सो हियर, बट देखो यहाँ पे अनडिफाइंड आ रहा है एंड स्टिल द फंक्शन अप्रोच इज, एंड यू कैन ट्राई एज ए गिवन द सिंपल एग्जाम्पल. द फंक्शन अप्रोच इज 12. जब भी x 2 के पास जाएगा देन दिस होल फंक्शन, दिस इज द प्लेस ऑफ द फंक्शन, दिस एंटायर फंक्शन इज वेरी क्लोज टू 12. राइट, हियर वन एग्जाम्पल इज देयर. आपको एग्जाम में हर बार ऐसा वेरीफाई नहीं करना है, बट MCQ में कर सकते हैं. अगर आपको नहीं आता है तो यू कैन यूज द सिंपल कैलकुलेटर एंड यू कैन प्रेडिक्ट, बट नॉट इन सब्जेक्टिव. बट आई एम जस्ट क्लेरिफाइंग द कॉन्सेप्ट ऑफ द लिमिट. ये कॉन्सेप्ट आपको क्लियर होना चाहिए कि भाई ये स्टेटमेंट का मीनिंग क्या है. ओके, सो दिस इज थर्ड इंपॉर्टेंट रिजल्ट. रिमेंबर, लिमिट x टेंड्स टू a x raised to n minus a raised to n upon x minus a is n into a raised to n minus 1. Limit x tends to a x raised to n minus a raised to n upon x minus a equals to n into a raised to n minus 1. That's the third important result. Right? 3 things as I told you. A number जो है वो यहाँ पे होता है. अब देखो यहाँ पे 2 है तो यहाँ पे 2 है दोनों जगह पे. दोनों पावर्स इक्वल होना चाहिए, ऊपर नीचे सेम साइन होनी चाहिए माइनस. सी दिस एग्जाम्पल, और एक एग्जाम्पल से बताऊँ. Limit x tends to 1 x raised to 10 minus 1 upon x minus 1. So whenever you see such bigger powers, immediately you need to recall this formula. So I can just write like that formula. मैं वो formula के फॉर्म में लिखूँ. x raised to 10, 1 को आप 1 raised to 10 लिख सकते हैं upon x minus a. Now we see it looks like exactly this formula. फाइन. और ए नंबर जो है वही यहाँ पे है. रिमेंबर, बीच में माइनस है दोनों जगह पे. सो व्हाट्स द लिमिट ऑफ दिस? नाउ यू हैव प्रिपेयर्ड फॉर्मूला. What's the limit of this? N into a raised to n minus 1. So what's the answer to this? 10 into 1 raised to 9. You take this one in the product and reduce the power by 1. इसको आगे ले लो, इसका एक power कम कर दो. So 1 raised to 9. So your answer will be 10. So whenever x is close to 1, then this function, this entire function is close to which number? 10. Again, you can take a number close to 1, put here, you will get a number which is very close to 10. Third, let's take one more example here. Suppose I have limit x tends to minus 1, x raised to 7 plus 1 upon x plus 1. Now, this is not exactly similar to our formula, so we can rewrite in that form. How? आप जानते हैं a number जो है वही यहाँ पे होना चाहिए. So limit x tends to minus 1, x raised to 7 minus 1 the whole raised to 7. You know, this will be minus 1 and in turn it is plus x minus 1. Now three things. At both the places your minus sign. This number is just same as this and both the powers are same. So now this is our standard formula. So what's the limit of x raised to n minus a raised to n upon x minus a? That is n into a raised to n minus 1. Take this number in product. So 7 आगे लिया into minus 1, one less power which is 6. What I did? Take this number in product and one power less which is 6. Now this is even number, so it will 1. So limit will be 7. So what it says, whenever function is very close to minus 1, then this is very close to 7. Just again for your reference, take values of x very close to minus 1. Take a number which is very close to minus 1. Put into this function. You will see that you will get a number which is very close to 7. You can try if you want. But otherwise by formula this is right. Okay, so this is example number 3. Now we go, result number 3 we did. Now we go to fourth result. That result says that if you have limit x tends to a, here I have some polynomial function. Polynomial function upon the polynomial function, upon one more polynomial function. Like this, such example. Here, limit x tends to, suppose I have 1, suppose I have like this. Let me write x square minus 5x plus 6. Polynomial, you know, it's a quadratic. Let me write here tends to 2, and upon you have x minus 2. Right? This is a polynomial, you know, in types of functions you recall. Polynomial upon the polynomial. Now, see here, what happens, अगर मैं directly limit apply कर दूँ, division rule से अगर मैं, if I do by division rule, तो यहाँ पे कितना होगा? X, applying limit means instead of x I'm putting this 2. So 4 minus this is 10 plus 6. Let me, fine. I'm just putting here values of x. So ये तो 0 हो गया upon putting 2 here, 2 minus 2 ये भी 0 हो गया. This 0 by 0 कौन सा form आया? Undefined form. So you cannot write that the limit doesn't exist here. ये तो undefined है, आप evaluate ही नहीं कर सकते. This is undefined. Right? So when you have such polynomial upon polynomial, and if you are getting undefined form, it means they should have one common factor. Which common factor? This minus this. This minus this. A factor common होना चाहिए. So what we do if you have polynomial upon polynomial? We factorize this. And x minus a factor into you have some expression. Upon भी वही होना चाहिए. X minus a into that x some expression. Then what we do? We cancel this. And then here we apply the limit. So we'll get the required limit. That's the procedure. This is not formula actually. This is one type of the technique to solve the limit questions. So how I do this question? अगर मैं ये method से करके लिख दूँ limit doesn't exist तो it's wrong. What I'll do? I'll factorize. So here you know factors x minus 2, x minus 3 upon x minus 2. This will get cancelled. So now this is x tends to 2. You are just left with x minus 3. Now you can apply the limit by working rules. तो इसका लिमिट 2 होगा, ये तो कांस्टेंट है, -3 होगा तो लिमिट इज -1. So correct answer is -1 here, remember. It means whenever x is very close to 2, then this function is very close to which number? -1. You try again for you. For example, you take x equals to 1.999, close to 2 लिखा है ना मैंने. अब ये कहाँ पे रखो? फंक्शन में रखो. 1.99 होल स्क्वायर माइनस 5 इंटू 1.999 प्लस 6 अपॉन 1.9999 minus 2. You will notice that ये जो आंसर आएगा that will be very close to -1 होगा. That's why the limit is -1. Right? If you want to verify. Otherwise by results you need to do. ये सब आपको sums में नहीं करना है. That's why I'm putting inside the bracket. I'm just explaining you the concept. Fine. So this is the fourth one. Now one more result, fifth one. Let's write. That's about actually trigonometric functions now. So that is limit x tends to 0 if I have sin x upon x, and one more, that is if I have limit x tends to 0 tan x upon x. Sin x upon x and tan x upon x, remember. Then here without proof I'm writing this is 1, this limit is also 1. Whenever x is very close to 0, then the values of the sin x upon x and cos x upon x both are very close to 1, remember. So these are the standard limits. Here are two things. Angle should be very close to 0 and ये दोनों equal होना चाहिए. This should be very close to 0 and both should be equal, remember. These two theta should be equal, angle should be equal. If I have this limit, for example x tends to 0, sin, suppose I have 4x upon x, so here you cannot write 1, remember. यहाँ पे 4x है तो यहाँ पे भी 4 होना चाहिए. तो I can do like this, limit x tends to 0, sin 4x, I want 4x here, so multiplying and dividing by 4. Fine. Now this is a constant, so that constant remains as it is. What's the limit of this by the above result? ये दोनों equal है, that's important. If 4x है या 20x है, just x है, that's not important. Angle should goes to 0. So this is always 1. So your correct limit is 4. 1 into 4. Fine. Suppose I have this here. Limit x tends to 0. Suppose let me write tan 3x upon just 2x. So how do I do this? These two angles should be equal. First I'll take 1 by 2 outside. You know one of the working rule. If you have constant, you can take it outside. So I have tan 3x. Now upon you must have 3x. What I'll do? Multiplying and dividing by 3. So by 3 into 3. So now this is constant, this is constant. These two angles are same, 3x, 3x. Though this limit goes to 1 as per this formula. A equal hona chahiye. That's what this result says. So 1 by 2, the limit of this entire expression is 1 into 3. So the correct limit is 3 by 2. That means whenever x is very close to 0, then this function is very close to 3 by 2, which is 1.5. That way we use this. We'll see some more examples in exercises. Question number 6, that's called, sometimes it's about inequality, remember. It's about inequality. If you have inequality in the function, so like this, suppose one function fx is between these two, gx and hx. So this is inequality. The one function fx is between which two functions here? Gx and hx for every x. This is given to you. And limit x tends to a of gx is L, some number. Limit x tends to a of hx is also L. So two extreme functions are very close to L. This function is close to L, this function is close to L. The conclusion is here, then this is the conclusion. Then the middle function is also very close to L. Right? That's the conclusion. What is the conclusion? If these two extreme functions are very close to L, here, this L, ये दोनों equal होना चाहिए. Then the middle function should also approach L. Right? This is sometimes called sandwich theorem. It looks that this function is sandwiched by these two. It's like this. देखो, these three persons are walking. These two extreme functions are two extreme persons going to this point. Right? These two functions are very close to L. Then the middle person or middle function should approach L. That's the conclusion. Right? These two extreme functions are approaching this number. Then the middle function or middle person must approach L. That's the conclusion. This much you are given. Inequality, two extreme functions are very close to L. Then this is the conclusion. Then function, which function? The middle function also approach to L. This is called sometimes sandwich theorem. This fx is sandwiched by these two, remember. That's why. We'll see. But normally this is useful when you have such inequality. So when you have questions based on inequality, you should use this. Here, I'm sorry, I forgot to mention, even if you have reciprocal, then also limit is 1. If you have x upon sine x, then also limit is 1. If you have limit x tends to 0, x upon tan x, then also, I've just taken the reciprocal. So then also limit is 1. So these are the very two important results about trigonometric functions. Okay, so I think I have almost covered all the results. Now in the next session we start with the exercise.